Hello, you're welcome back. All right, so we are going to be looking at Ohm's law. Okay, so Ohm's law, what does it state? Now, Ohm's law states that the current flowing through a conductor, okay, is directly proportional to the voltage or potential difference across that conductor. Now, for us to illustrate Ohm's law, look at this typical diagram of a conductor. Okay, that we actually supply voltage V by connecting it across a cell. This is a cell, okay, with a source voltage V. Now, once this connection is being established, what happens? Current flows. So, according to Ohm's law, the voltage across this conductor is going to be directly proportional to the current flowing through it. And of course, the condition of Ohm's law is that it must be at constant temperature, okay? So that's one limitation, right? So for Ohm's law to hold, that means it must be at constant. The temperature must be constant. So that's constant temperature. So if the temperature is constant, then the voltage, okay, supply across this conductor is proportional to the current that will pass through it. So we simply mean that the more I increase the voltage, the more current I get. Okay, as the voltage increases, current actually increases. And of course, in mathematics, if we should actually replace the sign of proportionality with an equal sign, then I will have to introduce a constant. Okay, and what's that constant? That constant is a constant known as resistance. So it is specific to the conductor that I'm using, okay? Every conductor have their own resistance, okay? They have their own resistance, a very specific value for resistance for each type conductor. And what is this resistance, okay? So it is this resistance that will make me to believe that the voltage, okay, may not really be equal to the current. So normally without the resistance, without this resistance, I would have said that voltage is equal to current. So resistance is what makes the voltage not to be equal to current. And it is this resistance that will make the voltage somehow a little lower than the current, okay? Or even more lower than the current. And that is why we call this, of course, this R being the resistance, okay, as an opposition. So every conductor that allow current to pass through it have some form of opposition to the flow of current. So it's a property of a material that actually opposes. So there are properties of materials that actually try to oppose the flow of current to it, and that is the resistance. Okay, so opposition to the flow of current. So, and of course, the resistance is measured in ohm. We know that already. Okay, yes, ohm. Of course, from Ohm's law. So please take note of that. So invariably now, as I said, as you increase voltage across a conductor, the current actually increases. So we simply means that for us to investigate whether Ohm's law is actually true, okay, whether Ohm's law is true, we draw a graph that will illustrate Ohm's law. And what is that graph? It is the graph of voltage against current. Okay, so we supply different voltage, okay, different voltage to this conductor, then we measure the current that passes through it. And of course, you know what we use measuring instrument, okay, to do that. So invariably now, for me to actually do that, illustrate how that happens, okay, um, in series with the conductor, I have to measure the current, okay. So, and of course, the device that I will use to measure the current is going to be ammeter. Then in parallel with that conductor, I have to connect the voltmeter. So anytime I change the voltage, I will measure the current passing through the conductor and also measure the voltage that I supply to it. Or I may not necessarily need to use voltmeter since I know the amount of voltage I supply to it. Okay, it's still going to be the same. So if I draw the graph, because we already know that voltage is proportional to current. So if you draw that graph, you are going to have a straight line graph that starts from the origin. Okay, so this is what you're going to have. So for Ohm's law to be obeyed, if I draw the graph of voltage against current, I will have a straight line graph. Okay, so this straight line graph, of course, will have a slope. Of course, you know the slope is going to be change in voltage divided by the change in the current. All right, so that's going to be the slope. So that slope of the graph, what is it going to be equal to? Of course, from Ohm's law, resistance, if I make resistance the subject, resistance is going to be equal to voltage or potential difference divided by the by current. Okay, so of course it's also known that if I should evaluate the slope of this graph, slope will gonna be equal to the change in the vertical axis, which of course that's change in voltage divided by the change in current. So that means the slope of the graph of voltage against the current gives me the resistance. All right, it gives me the resistance of that particular conductor that I actually use for that experiment. So I hope that is well understood. Okay, now though there are some devices, okay, that are just uh, custom made to oppose the flow of current, and they have a specific opposition, they have a specific resistance. Okay, those particular those particular material or substance that is manufactured to oppose current in an electrical circuit are called resistors. They are device, okay, device that opposes that is actually manufactured to oppose the flow of current. So the symbol for a resistor, okay, this is the electrical symbol you're gonna see for a resistor. Okay, we use this as the electrical symbol of resistor. We can also use this as the electrical symbol of a resistor. Okay, so I hope that is well understood, because all being said and done, we are gonna be solving questions. Okay, so let's start picking our questions one after the other. Okay, so here we have the very first question. It goes this way: an electric heater draws 8 ampere from 250 volt supply. What is the power rating? Okay, also find the resistance of the heater element. Okay, so now we are gonna be this question. Now we are gonna be solving question that deals with power. Okay, so now let me write the parameters. It's always ideal that you write parameters so that you know the formula to use. I was given current, and that current is 8 ampere, and of course the supply voltage I was given to be 250 volts. So now means I'm looking for power. So I'm looking for power. Okay, having or was given current and voltage. So which formula of power am I going to use? The formula of power that actually relates current and voltage, and of course that's going to be power is equal to IV. Remember, current times voltage. So that means the power is going to be equal to 8 times 250. Okay, so let's do that. 8 times 250 was that is 2000. So the power is 2000 watt. Okay, so we are also asked to find the resistance of the heater element. So from the power, okay, how will I get the resistance? Don't forget that power also has formula that relates it with resistance, and we know that it's equal to I square R. Okay, I hope you've not forgotten this formula. If you have, go back to that video. So now I want to find the resistance. So that simply means that resistance is going to be equal to the power divided by the current square. So the power is 2000 watt, then divided by the current. And the current is 8 square. So I'm having 2000. 8 square is 64. Okay, so let's do that. 2000 divided by 64. What do we have? So my resistance is going to be 31.25 ohm. So 31.25 ohm. As simple as that. Next question. Okay, here we go. All right, I'll bring it to the screen. Okay, this one goes like this. What will be the current run by a lamp rated at 250 volt 40 watt connected to 230 volt supply? Okay. Mm. So invariably now the power the power of the lamp, the power rated of the lamp is 40 watt. Okay, and that 40 watt, okay, is actually is what is the power it will dissipate at 250 volts. But it happened that it wasn't this 250 volt that was supplied to it. Rather, the voltage that was supplied to it is 230 volts. So for me to get the current it will draw, of course, the formula power is equal to current times voltage. So the current is going to be equal to the power divided by the actual voltage it actually, okay, it took. All right, the power is 40 watts, and the voltage that was applied to it is 230. So let's divide that. 40 divided by 230. So that's 0.17 ampere approximately. All right, so I hope that is well understood. Next question. All right, let's bring that up right to the screen. Here we go. It goes like this. A battery has an EMF of 12.8 volts and supplies a current of 3.4 ampere. What is the resistance of the circuit? Okay. So the EMF of course, you know, EMF is also the same as the voltage. Okay. So the EMF is 12.8 volts. And of course, it supplies a current of 3.24 ampere. So what resistance of the circuit? What is the resistance of the circuit? Okay, so applying the formula V is equal to IR. So R now is going to be equal to V all over I, okay? So that's going to be equal to 12.8 divided by 3.24, okay? So that's simple. I believe you can actually do that. Now, okay, let me still do that. Let me 12.8 divided by 3.24. Okay, so approximately that's 4 ohm, right? Now the question: how many coulombs leave the battery in 5 minutes? So if you are looking for charge, the coulomb, how many coulombs is actually the quantity of charge? That's what they're looking for. So of course, it is current that relates. All right, remember, current is always equal to quantity of charge. Okay, flowing through a conductor per unit time. So invariably now, if I should make the quantity of charges the subject, that's going to be equal to current multiplied by time. All right, the current is 3.24, and the time we are asked, the time is 5 minutes. Okay, so that's going to be 5 minutes. I have to convert that to seconds by multiplying by 60. So this 3.24 times 5, then times 60. So that's 972 coulombs. So I hope that is well understood. Okay. another question before we now look at combination of resistors. Here we go. If a resistor is to dissipate energy at the rate of 250 watts, okay, so the energy that the resistor will dissipate is at the rate. So the rate of energy is power. So what they are giving us there is actually the power, right? The power is 250 watt, and of course the SI unit will tell you that it's power. All right, 250 watt. Find the resistance. Question mark. Okay. For the terminal voltage of 100 volts. So now we're looking for resistance, okay, having been given voltage and power. Remember the relationship. So the relationship between power and voltage along with resistance is V square all over R. Hope you can still remember. So if I should cross multiply now, I have I make resistance the subject. So resistance is going to be equal to V square then divided by the power. So the voltage is 100. That's 100 square divided by the power, which is 250. Okay, so let's do that. Okay, so that is 100 square then divided by 250. What do I have? 40. So 40 ohm. Okay. All right, so we're going to be discussing the different way resistors can be connected, okay, different combination of resistors in series and of course in parallel, okay, then after which we are going to solve more questions. All right, so see you in the next video. Thank you very much.